Before we talk about the lead storage battery, let's look at this unique oxidation reduction reaction. We'll start by assigning oxidation numbers. Br2 is bromine in its elemental state, so it has an oxidation number of 0. When we look at NaOH, that is not a peroxide, so oxygen will have an oxidation number of -2. Hydrogen will have an oxidation number of +1. The whole compound must be neutral, so if we have a -2 on oxygen and a +1 on hydrogen, sodium must be a +1. We also know sodium's a +1 because if this is an ionic compound, which it is, sodium ions would be +1 because they are in group 1 of the periodic table. So if we look at sodium bromide, well, we know sodium is +1. Bromine is in group 7 of the periodic table. All of those substances would have a -1 charge on their ion. Bromine is a -1 in this case. Over here, bromine will not be a -1. Let's check this out. We know sodium is a +1. We know oxygen is a -2. So if we do our equation, this whole compound must be neutral. So we know we have 3 oxygens, each with a -2 oxidation state. That gives us a total of -6 from the oxygen. And 1 sodium means a +1 from the sodium. So what is missing in order to get 0? In this case, bromine's oxidation number is a +5. Over here, we have H2O. And H2O, hydrogen is always +1, oxygen is always -2. So now that we have the oxidation numbers assigned, we can see why this is a unique example of an oxidation reduction reaction. The same substance is both oxidized and reduced. Check it out. Bromine goes from an oxidation state of 0 to +5. That is a loss of electrons, which is oxidation. In this case, it lost 5 electrons. Bromine also is reduced to Br-, 0 to -1 oxidation number means the oxidation number is reduced because electrons are gained, and in this case, 1 electron is gained. To even out the number of electrons, we need to multiply the oxidation by 1 and the reduction by 5. So in this reaction, there are a total of 5 electrons that are transferred. Because we multiplied the reduction process by 5, we can put a 5 in front of Br2 and in front of NaBr. Since we multiplied the oxidation process by 1, we could put a 1 in front of Br2. We already had a 5 there, so we don't have to put anything there, and a 1 in front of NaBrO3. And now we can balance it from there. These coefficients are going to remain the same. So if we balance from there, we can see we have 5 sodiums here and 1 sodium here. So on the reactant side of the reaction, we will need 6 sodiums. So we can put a 6 there. If we look at the bromines now, I have 5 bromines here and I have 1 more bromine there. I only have 6 total bromines on the product side. But over here on the reactant side, if I take 5 times 2, I have 10 total bromines. Well, that number then can be changed here. We can change that 5 to a 3 to balance the bromines. And the last thing we need to do is determine the coefficient for water. So if we look at the hydrogens here, we have 6 hydrogens on the reactant side. So we need 6 hydrogens over here on the product side. So we should be able to put a 3 there. And everything should balance. We can check our oxygens. Notice here we have 6 oxygens on the reactant side, and here we have 3 oxygens on the product side, and then 3 more in H2O. So this reaction is now balanced. It's a unique oxidation reduction reaction because the same substance, Br2, is both oxidized and reduced.